Hello students, how are you? I hope all of you are fine and staying at home safely. This is your teacher Nasim Ahmed from Ideal Public School Katigura. In this video series, I am explaining chapter 9 of class 9, force and laws of motion. In the last 3 videos, I have explained force, then I have explained Newton's first law, then second law, and today in this video I'll be explaining Newton's third law of motion, and along with it we have one more topic. This is conservation of momentum. So in the last video we have understood about momentum. In this video we'll be understanding conservation of momentum. So without any further ado, let's get started. So students, before going through the statement of Newton's third law of motion, we have to understand two terms here. One is action, another one is reaction. So two forces acting from opposite direction are called action and reaction forces. For example, you see a ball when hits the ground, that will be called as action, bounces back with a certain force, that will be called as reaction. So we know about action and reaction. In the diagram you see this ball is hitting on the ground. This activity is action, and after hitting the ground it bounces up. Okay, it bounces up, that will be called as reaction. So we'll need this concept of action and reaction while understanding Newton's third law of motion. So let's jump into the Newton's third law of motion. Let's see what the statement is. Okay students, let's see the statement. The third law of motion states that when an object, listen very carefully, okay, this is very important law of Newton. Earlier two was important, but this one is very important because from this you have so many numericals to solve. So you see the statement, when an object exerts a force, on another object, the second object instantly exerts a force back into the first object. So when an object exerts force on another object, this will be called as action, and when the second object instantly exerts a force back into the first object, that will be called as reaction. Okay, these forces are always equal. Very important term here, always equal in magnitude. Okay, you have to remember this, but opposite direction. So both of the forces will be always equal in magnitude but opposite in direction. So we'll be understanding this with an example. Okay, see the example. When a bullet is fired from a gun, the gun only moves a little backwards. That will be called as recoil, while the bullet can travel a large distance. This is because of the difference in the mass of the bullet and the gun. So simply we can understand the statement, this Newton's third law of motion from this example. See this gun. Whenever a gun fires a bullet, then what happens? The gun, after firing, the gun pushes backward. Okay, pushes backward. So here you see accelerating force on a bullet. This bullet is going by this direction, and due to the movement of this bullet, the gun goes backward. Okay, it has some recoil, we can say. It moves little backward, so that will be called as recoil. Okay, so this is a very good example of Newton's third law of motion. So the firing of bullet is what? Action, and this movement of the gun in the backward direction is called reaction. Okay, so in other words we can say every action has an equal and opposite reaction. In one line, if you want to conclude this Newton's third law of motion in one line, you can say every action has an equal and opposite reaction. So I hope you are understanding. Let's see. The magnitudes of force acting upon the object are same, but the acceleration produced in them may or may not be same because the objects can differ in masses. So you see, in case of this this example, you can see this bullet, after firing, it is going so much far, but this gun is just like this. The movement of the gun is very little, okay, in comparison with the movement of the bullet. So why it is happening? because of the masses. This bullet is having less mass, okay, that's why it is moving so much far, so the velocity is more. Okay, that means we can say acceleration is produced after this action is more in case of bullet, but in case of gun it is very less because of the difference of the mass. So I hope you have understood. Okay students, now we'll be discussing about conservation of momentum. This is the second topic of today's lesson. So let's see the statement first. As per the law of conservation, as per the law of conservation uh, of momentum, the sum of momenta of two objects before the collision and after collision remains the same, given that no external unbalanced force acts upon them. Very simple statement we can say. Just listen carefully, you can understand it easily. So we have three cases here. Okay, we have three cases we can say. One is before collision, then you have during collision, then after collision. Okay, so before collision means two balls are there. If you consider, like, we'll go through it. So first understand the statement. As per the law of conservation of momentum, the sum of momenta of two objects, so we have to consider two objects, then the sum of the momenta of the two objects before collision and after collision remains the same. So like if we have two bodies, then both of them will be having two different momentum. Okay, two different momentum. So before the collision, and if after some time, like when they are separated from each other, and after some time if they collide, then after collision they will again be separated. So before, if you measure the momentum, the sum of the momentum before collision and after collision, you will find both of them, in both of the cases they are same. Okay, and the condition is that no external unbalanced force acts upon them. Okay, if no unbalanced force, external unbalanced force is applied on them, then they will be having same momentum before collision and after collision. So we'll understand it from this, we can say, experiment. Okay students, so consider the figure given above. So we have to consider this figure. Two balls A and B, this one is ball A, this one is B, as written, having a certain initial velocities collide with each other. So after, like, we are considering that both of them are having some kind of like some velocities, okay, initial velocities, then after that they have to collide. Okay, and there are some conditions in this case. You see, there is no unbalanced force acting upon them. So there is no unbalanced force, like you are not applying any kind of external force on them. Then the second point is the initial velocity of A is greater than the initial velocity of B. Okay, so we need the collision. So if we need the collision, then the velocity of A should be greater than the velocity of B, obviously, otherwise it will not collide with each other. Okay, so let's see from this consideration what we get. So students, we know about momentum. How we find out momentum? We find out momentum, so we denote momentum with P, and momentum is the product of mass and velocity. Mass and velocity. So if we consider the momentum of ball A before collision, so we are considering the case before collision. Okay, so you see mass, what is the mass? M1, because if we name this ball as A, then the mass will be M1, and for the case of B, the mass will be M2 as given here. So what is the momentum of ball A before collision? This mass is M1 and the velocity is U, as we have said, M1, or we can say MA. Okay, so if we consider this ball as 1, then this ball is 2, then we can say M1 and M1 and M2. But if we consider A and B, then we will say MA, UA. UA is what? The initial velocity of ball A. Then the momentum of ball A after collision, then we know initial velocity we denote it with U, and final velocity we denote it with V. Okay, so the momentum after collision, what it will be? Mass into velocity. So mass is Ma, as this ball is not changing, but the velocity changes. Initially it was U, so we have denoted it with UA. You see UA, and now it is VA. Okay, this is because it is final velocity. Okay, so similarly we can say the momentum of ball B before collision is mb ub, as we have mass of ball B is mb and the initial velocity of ball B is ub. So the product of this will be the momentum of ball B before collision. Then the momentum of ball B after collision, what it will be, we'll just change it mb vb. Okay, vb simply. So students, now we'll be talking about only ball A. So we need to find out the rate of change of momentum of ball A. So how we find it? We just need to find out the difference in the momentum before the collision and after the collision, and then we have to divide it with t, because rate of change, we know this, that the thing will be divided by t simply. Okay, so if we write the difference here, so we will be writing the moment, we have to minus the momentum of ball A before collision from the momentum of ball A after collision simply. So what is the momentum of ball A after collision? M A V A. So we have to minus it, minus M A U A. Okay, so we have to minus M A U A from M A V A. Then we have to divide it by T. Okay, then we can find out the rate of change of momentum of ball A. So we can take common ma, then in the bracket what will remain? Va minus ua. Okay, you can see here. So that will be called as force of action of fab. That means force of A upon B. Fab, A is in the first position, that means force of A upon B, force of A ball upon B ball. Okay, so if I find out the rate of change of momentum of ball B, that means ma, in case of A it will be mb, simply mb vb minus mb ub. Okay, so rate of change means divided by t. So we can take common mb, then what will remain in the bracket? vb minus ub, you can see here, divided by t. That thing will be called as force of reaction. Like this air ball is having more velocity, that means it will strike the ball B, then the collision will happen. So after the collision, the ball B, like during the collision, the ball B will exert some kind of force on A, that will be called as force of reaction of B upon A. Okay, so first, in the first place, FBA, like in the first place it is B, that means force of reaction of B upon A. So if we say according to third law of motion, we know this FAB is equal to minus FBA. So why minus? Because this negative sign shows opposite force. As we know, action and reaction both are equal in magnitude, but they are opposite in nature, we can say, or their direction is totally opposite. So that's why this minus is given. Okay, so FAB equals to minus FBA. So we will put the values MA into VA minus UA divided by T equal to minus MB into VB minus UB divided by T. So here T in both the sides of the equal sign, T and T both are denominator, so we'll cut that out. Then what will remain? We'll multiply MA into VA minus MA into UA. Then this minus plus minus minus, it will be MB into VB, then minus minus it will be plus MB into UB simply. So this one we can write. So we'll just take this final momentum of like not final, we can say after the collision momentum of both the balls to, in a side. So this MAVA, this MBVB will be coming in this side of in the left side of this equal sign. Then this minus will be changed to plus. Then this side you see MB MBUB is there, MAUA will be going in the right side, this minus will become plus simply. Or we can say MAUA plus MBUV equals to MAVA plus MBUV. So simply we can say momentum before collision equal to momentum after collision. So this is the what? This is the addition of both the momentum of the balls, both the balls, okay, momentum of both the balls before collision, and this is the total momentum of both the balls after collision. So before collision is equal to momentum after collisions. Hence we can say the statement that said what it said, the sum of momenta of two objects before the collision and after collision remains the same given that no external unbalanced force. So this is considered here that no external unbalanced force is acting upon it. So our statement is proved, we can say. So this is a mathematical derivation of the third conservation of momentum. So if you have any question regarding this mathematical derivation of this conservation of momentum, you can ask me in the WhatsApp or in the comment box here. Anywhere you can ask me, or you can directly call me and ask me directly. So I hope you have understood. If you have not understood, then my door is open for you. So that's pretty much it for today. So in this video we have understood this Newton's third law of motion, then law of conservation of momentum, simply conservation of momentum we can say. So this is I think the last video of this series, of the explanation of this series. Only one video is remaining. There I will be coming up with numericals of this chapter, full chapter in one video I will be doing. So we know these formulas, we know how they are derived, so we know what are the parts of the formulas. So we'll do it. I will be coming up with different questions. So I'll be giving you homework also, and notes are also provided to you. So you just go through the notes, and if you have any doubt you can ask me. Okay, so study hard and God bless.